Good morning. Today is Wednesday, May 6th. I'm going to pull up our camera so you can see. Make sure you have your checklist out. This is how we're going to keep focused on what we need to work on. So we're going to check in with what we learned yesterday by looking at page 868. Then we're going to do our fluency, which is a spiral review. I can convert U.S. customary measurements. We're going to continue working on mass and metric. The standard is I can convert metric measurement. And then your exit ticket today is at the bottom. Please make sure you're taking a picture and sending that to me every day, or opening a Google document and sharing that with me every day. All right. Yesterday, you should have finished your Check Your Progress, finished your lesson 11, worked on the homework if you wanted a challenge, worked on the algebraic pay and balance if you wanted a challenge, and then measured those 12 objects and recorded them either in your packet or sending me the measurements in Dojo. All right, so we're going to backtrack a little bit to get your brain back thinking about metric measurement. If you haven't already answered the questions on page 868, questions 16, 17, and 18, please go ahead and stop the tape and make sure that you've answered each of those 3 questions. All right, if you are measuring the mass of a container of salt, would it be better to use grams or kilograms to be more precise? If you have not already seen, this question is in every single lesson. They really want you to understand this. So which measurement is the more precise measurement? It's always the smaller measurement. So we have kilograms and grams. The smaller measurement is more precise. In this case, grams. Compare and contrast, which means same and different, grams and kilograms. So what type of measurement are they both? Both metric measurement. What are they both measuring? Length, mass, or capacity of liquids? Both measure mass. How are they different though? One is small and one is large. How can I convert from grams to kilograms without measuring? So grams to kilograms, small to big, 3 stair steps. So are you going to multiply or divide? And what power of 10 are you dividing by? 10, 100, 1,000. All right, we're going to jump right in. So you should be finished with all of your work in your old packet, and we're now in our new one. Your new one looks like this. You have 3 different ones because it was so many pages, or actually these are in your book because I didn't even rip them out. So we're on page 871. I think I had to rip one student's out to make copies. All right, but we're going to start with our warm-up. So your warm-up is behind your calendar. I can convert U.S. customary measurements. We worked on this 2 weeks ago, 3 weeks ago actually at this point. All right, so before we get going, let's remember our conversions. How many inches are in a foot? I'm just going to write these to the side. 1 foot equals 12 inches. How many feet are in a yard? 3 feet. So remember, these you have to memorize. This is a ruler. A ruler has 12 inches. A yard is like holding your hands out from tip to tip, and it's 3 feet. All right, now these they're going to give you. They won't ask you to remember these. So 1 ton is 2,000 pounds. Remember, LBS stands for pounds. And every pound has 16 ounces. All right, so here we go. We're going to write our little anchor chart. Take a moment and write it before I write mine. If you don't practice it, you won't be able to use it when you need it. Big to small, divide. Small to big, multiply. Oh, I wrote it backwards. Miss Dunnigan needs more coffee today. Because we need fewer of these, so our number gets smaller. We need more of these, so our number gets bigger. All right, here we go. We're going feet to inches, big to small, or small to big. Big to small, which means we need to multiply. So now we find our conversion. 2 feet with 12 inches in each, 24 inches. All right, we're going to do one with a divide, and then I want you to finish the other ones on your own. 36 inches to feet, so we have small to big, which means we divide. We're still in our formula of 1 to 12. 36 divided by 12 is 3. All right, go ahead and press pause on your tape and finish your conversions. Remember, how our brain learns is that the more we practice, the stronger that learning bridge gets. So it's really important that we don't just drop these skills and forget them now that we've moved on, that we keep practicing them a little bit every day. It'll make that bridge much, much stronger. All right, so if you're with me, you've already completed your problems and we're going to check them. No cheater, pumpkin eaters. Feet to yards, small to big, which means we divide. Our formula is 3. 9 divided by 3 is 3. Yards to feet, big to small, which means we multiply. Every one of my yards has 3 feet. 27 times 3, 81. Tons to pounds, big to small, multiply. My formula is every ton has 2,000 pounds, so 2 tons has 4,000 pounds. Pounds to tons, small to big, divide. Ooh, this one's tough. What's 3,000 divided by 2,000? I'll write it down here. Remember, a division problem is just a fraction. Divide by 10, divide by 100, divide by 1,000. What's 3 over 2 as a mixed number? 1.5. Pounds to ounces, big to small, multiply. My formula is here. 16 times 3, 48. Ounces to pounds, small to big, divide. I need 64 divided by 16 is 4. All right. Your exit ticket for today that we can kind of get in our brains ready to go is how's measuring metric and customary alike and different. So that's a compare and contrast. You're going to need a sentence about how they're alike and how they're different. And it has lines for you, so please make sure you're writing in full thoughts. All right, we're going to put this to the side. And we are on page 871 in your book. You can either rip the pages out as you finish them, or I recommend you just keep them in your book and rip them out.